Okay, so let's start with O levels and IGCSE physics past papers for elastic deformation. So let's see question number one. A load extension graph for a spring is shown. Okay, so a load extension graph for a spring is shown. Which point is the limit of proportionality for the spring and what is the spring constant of the spring equal to? Can you see this point Q? This is the point till which the force versus extension graph is linear. Hence, this is your limit of proportionality. This is your limit of proportionality. You can say Q is your limit of proportionality. C and D will get cancelled out. What is your spring constant? Spring constant is the gradient of force versus extension graph before limit of proportionality. So it is the gradient of line PQ. A is your answer. Let's further move ahead. 1 second. Yeah. Let's see this. A spring is stretched to different lengths by a variable force. Okay, the graph shows how the size of the force depends on the length to which the spring is stretched. Okay, so this is force versus length graph. You have to calculate the spring constant. Can you see when the force is 0? When the force is 0, the length is 10. When the force is 0, length is 10. This point becomes 10, comma 0. And let's say when the force is 8. When the force is 8 y-axis, the length is 30. Okay. Can you calculate the spring constant now? Yes, you can just calculate the gradient of this graph. Y2 is this is x2, this is y1, this is x1. The gradient will be equal to what? Y2 minus y1 over x2 minus x1. Y2's value is 8, y1 is 0, x2 is 30 minus 10. This comes out to be 8 over 20, that is 4 over 10, that is 0.4 Newton per centimeter. Sir, how did you get the units? Can you see on the y-axis we have Newton, on the x-axis we have centimeters. So the unit will become Newton slash centimeters. B is your answer. Let's further move ahead. The graph shows how the extension of a spring changes with masses suspended from the spring when it is on planet X and when it is on planet Y. Okay. So these are four mass versus extension graphs for planet X and planet Y. Okay. What conclusion can be drawn from these graphs? Okay. If you focus closely, the same mass of 2 kg, let's say the same mass of 2 kg, is causing an extension of 30 on planet Y and is causing an extension of is causing the mass of 2 kg is causing an extension of 10 on planet Y and it is causing an extension of 30 on planet X. So that means the same mass is causing thrice the extension on planet X. How is this possible? This can only be possible if the force on planet X is 3 times. Now, how can the force on planet X be 3 times? It is only possible in one way. Weight is equals to mg. If your gravitational field strength of X is 3 times the gravitational field strength of Y, then your weight at planet X will become 3 times, or you can say the force on planet X will become 3 times. Is there any option like that? The gravitational field strength on planet X is 3 times the gravitational field strength on planet Y. D is your answer. Let's further move ahead. A metal wire is stretched by a force up to the limit of proportionality. Okay. Describe what happens when F is slightly increased. If you increase F beyond limit of proportionality, what will happen? Your graph of force versus extension will start to curve. It will no longer remain linear. The wire breaks? No. The wire continues to extend but not in direct proportion to F. Yes, this can be my answer. B is my answer. B is my answer to this. Let's further move ahead. Where on the graph is the limit of proportionality for an elastic solid? Okay, in this entire graph, where is the limit of proportionality? The limit of proportionality is the point till where the force versus extension graph is linear. Where is that point? That point is P. B is your answer. Let's see this. This is slightly blurry, sorry for that. A weight of 2 Newton is hung from a spring. The extension produces 6 centimeters. Okay, so force ratio is string 2 Newton force causes an extension of 6 centimeter. Okay. The 2 Newton weight is removed and an 8 Newton weight is hung from the spring. Okay, now an 8 Newton weight is hung from the spring. What is the new extension? We have to calculate the extension new. What will we do? We will cross multiply 8 multiplied by 6, 2 multiplied by e. So 2e is equals to 8 into 6. E is equals to 8 into 6 divided by 2. This becomes 1, this becomes 4, this becomes 24 centimeter. Is there any answer like that? B is your answer. Let's further move ahead. Which point marks the limit of proportionality? Obviously, it's very, very easy. If you draw a straight line here, the graph starts to curve at point B. So B is the limit of proportionality. Simple. Let's see this. An unstretched elastic cord has a length of 15 centimeter. Okay, so this is L naught. That is the unstretched length. That is the unstretched length. It stretches by 4 centimeter when a weight of 6 Newton is added. Okay, so force ratio extension. 6 Newton force causes an extension of 4 centimeter. The cord does not exceed the limit of proportionality. What is the total length? LT. Do you remember that total length is a sum of unstretched length plus the extension? When the weight is 3 Newton. So if the force is 3 Newton, what will your extension be? X. Cross multiply it. 6x is equals to 12. X is equals to 2 centimeter. This is your new extension. This is your new extension. Now you had to calculate the total length. Total length is equals to L naught plus the new extension. What is L naught? 15. What is the new extension? 2. The answer comes out to be 17 centimeter. D is your answer. Let's further move ahead. A load L is suspended from two springs that are parallel. The extension of each spring is X. Okay. Here, if you can see, a load L is being applied. This spring will get L upon 2. This spring will get L upon 2. Hence, this spring will have an extension of X. This spring will have an extension of X. Okay. The springs are then rearranged to hang vertically as shown below. Okay. Now, this spring will have L force and this spring will have a force of L. Can you see the forces have doubled from L upon 2 to L? The extensions will also double from X to 2X. This will also become 2X. The total extension will become 2X plus 2X. That is 4X. D is your answer. The diagram shows a graph of load versus extension. Which point is the limit of proportionality? A. Very easy to visualize. After A, the graph starts to curve. Let's see this. The graph shows extension load curves for 4 fibers. Which fiber is the most difficult to stretch? Okay. So let's say I have a force of 2 Newton here. My spring D, let's say, gives me an extension of 1. Spring C gives me an extension of 1.5. Let's say spring B gives me an extension of 3. And spring A gives me an extension of 5. The most hardest to stretch is D. Why? Because at a force of 2 Newton, it is giving the least amount of extension. D is your answer. Let's further move ahead. The graph shows the extension of a piece of copper wire as the load on it is increased. What does the graph show? The graph shows that here might be the limit of proportionality, and after that it is starting to curve. Okay, one thing that you need to remember, after limit of proportionality, your spring becomes easier to stretch. So let's see, at a certain load, the wire becomes easier to stretch. Yes, A is your answer. And what is that load? What is that certain load? After limit of proportionality, wire becomes easier to stretch. Simple as that. Let's further move ahead. What some students plan to use a spring to make a spring balance with a linear scale. The graph shows how the extension of the spring changes with the load on it. What is the total range of a balance with linear scale using the spring? Okay, what this is a complicated way or sophisticated way to ask till where is the limit of proportionality. Limit of proportionality is till 10 Newton. After that, the graph starts to curve. So, is there any option like that? 0 to 10? Yes. A is your answer. Which object behaves as an elastic solid as it deforms? Okay. Which object can you can say compress and stretch? Can a bullet compress or stretch? No. Can a car compress or stretch? No. Can a piece of metal compress or stretch? No. Can a football does that? Yes. Let's see this. A spring extends by 6 centimeter when a weight of 15 Newton is suspended from its lower end. Three of these springs are used to show support at a 90 Newton weight. Okay. So if this is 90 Newton, this spring will be getting 30, this spring will be getting 30, and this spring will be getting 30. And you know that 15 newtons causes an extension of 6 centimeter. 13 Newton will cause an extension of x. Cross multiply it. 15x is equals to 30 into 6. X is equals to 30 into 6 divided by 15. Your answer comes out to be 12 centimeter. Simple as that. Let's further move ahead. Yeah, this was the last question, I guess. So this marks the end of past papers for elastic deformation. If you have any questions, you can ask in the comments below. The PDF is attached in the Google Drive link. Thank you for watching.